In the shadows of your spreadsheet, something's not calculating. Jack, Elliot, and Dim, investigating the strange, explaining the unexplained. The Excel Files. Trust no cell.
Welcome to episode 3 of the Excel Files podcast. I'm Jack Kennedy.
Patterson.
I'm Dermot Early.
And for today's guest, we have the wonderful Mr. Jeremy Freelove. Welcome to the podcast.
Thank you.
Welcome, Jeremy. I don't know if you've listened to the podcast before, but generally what we do is we just chat about all things Excel Esports and tend to maybe get a little bit technical. In today's episode with Jeremy, we will be covering, the topic is called Excelling with Algorithms, and I believe we are covering algorithms and their use in Excel Esports.
Yeah.
Sounds fun.
Excellent. Now, we do have, I feel like this could be a bit nerdy-outy, because we do have Dr. Dim over in the corner, whose doctorate is explicitly in, is it specifically algorithms?
Yep. Running time of algorithms. Mm-hmm.
The running time of algorithms. Did you literally just run millions of sorting algorithms for your doctorate? And see what was fastest.
Let's say that I did. That's what theoretical computer science looks like.
Dr. Big O, I thought you were known as.
That's terrible. You should be ashamed of that.
It's what I heard they called you.
I'll have you know I am licensed to tell jokes that bad because I am a dad.
I'm a dad in spirit. I was born with that comedy.
I thought that gene just kicks in at a certain point, but yes. So that's today's topic. We will be. Jeremy, can you tell us why this topic appealed to you?
Well, good question. Number one, because I couldn't think of much else. I was struggling to come up with topics, and maps seemed really good. There's been a lot of activity in the map arena of the Excel Esports lately, and algorithms kind of ties in with that, especially with a lot of the work some of the people are doing now. Hayden's lambdas. I've done my own. I think other people have various pathfinding type of algorithms for their lambdas now. And if we just kind of take a step back and go through the meta of the game, so to speak, you know, when I first started 2 or 3 years ago, it was all about dynamic arrays, right? We had a shiny new tool, and if you were new to the scene, you might have catched Deerwood's channel and seen him breeze through some of these channels in like insane amount of speed. And it's just like, how do you do that? So you spend, I don't know, I spent 6 to 12 months catching up on dynamic arrays, learning how the lambda helpers map, reduce, etc. And just as you're getting confident with that, the game kind of changes or it evolves over time. You start seeing more maps. You start learning, my X lookups and my index match and my if statement, competency is not taking me to wins right now. I'm going to have to learn how to navigate maps and, do indirect lookups of values on another tab and things like that. So the meta of the game seems to evolve, at least at an individual level. I don't know if it's the same pace for everybody else, but I've gone through kind of stages of evolution in my game. And where I kind of see this going now for this year is algorithms. I'm catching on that there's perhaps, I don't know if this just comes out organically or if there's intent behind it, but when the case designers write these cases, they're striving for something new. And a lot of the times, since we've already kind of hashed all the amount of lookups that we can do, That may not be true, but they're expanding their direction into problems that are more creative. And these types of problems, sometimes you can brute force them or figure out creative ways to do them in Excel. But if you have an algorithmic approach to some of these things, then it helps you learn new topics and new subjects. So it's always keeping me fresh like that, and I enjoy learning. And two is like, if the more prepared you can come into these battles, perhaps anticipating what you might encounter, then you're going to be more prepared than the next guy. And that's kind of what this whole battle is about, it seems to me. So that's how I picked algorithms. I think that there's a lot to cover there, a lot of ideas to talk about. I'm eager to learn from Dim.
Excellent.
I also feel like I think I agree with everything you just said. And the other thing I would add is I feel like algorithms are the sort of natural next frontier of the sort of Lambda arms race, because not every single one, but like most of the Lambdas that people have written and used up to now have been like small utility things, like, oh, it's a real pain to have to like type out mid-sequence len every time, so I'll just have letters, boom. And now it's like with some of these complex algorithms, like, you know, the kind of maze pathfinding on variable distances, or like, you know, Bo did a thing on the Hungarian algorithm recently. You know, like writing that algorithm as a function is an hour of work if you don't make any, you know, obviously dumb mistakes. And so there's no way that you're going to do it on the spot during a round in the way that with a lot of others you could just say, oh, whoops, I don't have my lambdas here, I'm just going to write it. And so it's a whole new frontier. Obviously, you know, the more specialized the algorithm is, then, you know, the more you have to ask yourself, am I really going to write an algorithm for an hour that's going to help me in 3 more cases in the rest of forever? Probably not. But on the other hand, if one of those cases comes up and the guy you're up against has an algorithm already written as a lambda, then you're dead. So it's it's just another angle to it.
And
So
that
Jeremy,
is an interesting trade-off. It's like you never know if what you're doing is going to pay off in some way.
Yeah.
But I would say that for most people, especially if you're not already super well versed in algorithms, that the stuff you're going to learn at the beginning is going to expand and help so much, and at least teach you ways to think about problems and break them down into smaller sub-problems. And you know, I'm sure all this is covered easily by a computer science person, but you know, I have an accounting background. I didn't learn any of this in school. Never took a computer science class in school.
that's what I was going to ask you, Jeremy. Was given your current love for algorithms, did you have much of a background in it or much programming? But sounds like the answer is no.
Not formally speaking. I mean, I was always a nerd. You know, I loved, you know, playing Tetris on my TI-89 calculator. So there was always a bit of coding in the background, whether it be HTML or PHP at some point, and you know, small things that you would just tinker on your own, but never went that way from a academic sense.
Yeah, that's really interesting. Obviously, Dim, you've got quite an experience. I think Jack, you had a little bit of experience early on. I've done a little bit of coding in the past, not formally, but informally. And certainly, one of the sessions I gave for Full Stack recently, I was talking about using the iterative number approach. I think Craig Hatmaker does a lot of the similar stuff, and I've seen Bo do similar stuff as well. But using by row or reduce with sequence to be able to get multiple, you know, the corresponding row out of different columns and that sort of thing. Very, very coding type logic in Excel, which, as you say, in the past few years really has exploded, both in this scene and elsewhere. At a time when still the average user is still shocked to find out that tables are a thing.
I mean, when you think about the average Excel, it's such an odd concept. You know, if there are whatever 750 million or a billion users, I remember, I cannot remember a source for this, but I think the thrust of it is right, that like someone, I think maybe Microsoft, had done some, you know, meta-analysis of a whole bunch of spreadsheets they had collected data on at some point, and their conclusion was, as far as I remember, something like it might have been 99%, and north of 90% of spreadsheets that did not have a formula in them at all. They were just like lists or
Oh, wow.
grids or whatever. So like you think about the average Excel, like the median Excel user uses no functions. So there's like I think people often talk about the average Excel user when they mean the average person in a finance department whose job is to work with Excel all the time, but maybe isn't the most cutting edge about it. But actually, that person is probably 98.5 percentile or something.
I think when you combine that, because I've heard that stat before as well, but if you combine that with the who was it? Was it Deloitte or someone did the study that said something 60% or something had an error? And it's like if 99% don't have formulas in, that means there's probably a large chunk that've got errors in without any formulas. So it just shows you at what level.
Maybe the error is just that everything's been hard coded because someone sat there, put some numbers into a spreadsheet, then took out their calculator and started typing out numbers and putting the answers in directly.
I do know my brother was told by his boss that they couldn't use his version of the spreadsheet because they didn't understand all this formula stuff. And he did have just the numbers in. And that was like...
Another friend of mine had a similar experience. He was like berated by his boss for this, like, what kind of shoddy shortcuts are you taking when he was using the sum function to add up a bunch of numbers, because he should have taken out his calculator, typed them in one by one, and then put in the answer, because then you know it's right.
A calculator, Tim, come on, abacus, surely.
I mean, those are absurd examples to the one extreme, but there kind of is a situation now with dynamic arrays where, when you're in charge of, let's say, an accounting department, you kind of have to be aware that not everyone can read the formulas that you can write. And so what's the trade-off here? Efficiency versus understandability and auditability and things like that.
Yeah, I guess
Absolutely.
you must have to think about that a lot as like someone who is individually totally cutting edge, but also has to manage a team. That's a challenge.
Sure. And I do not have the answer to that question yet. I'm still struggling.
No, absolutely. And it's one of those things which I talk about in my team quite a lot, in terms of if you were doing straight up coding, people would just accept the end product and use what is service to them. Likewise, a lot of what we do is through Tableau and that sort of thing, Power BI sort of stuff. At which, people, you can give them some level of control with slices and buttons and whatever else, but they sort of largely accept that the data they're shown is right. Give them any form of Excel spreadsheet, even if they don't understand the formula. They're in there, breaking any controls you've got, breaking anything they can, trying any sort of hack to try and get around anything you've put in to hold things in place. But it's this thing of everyone. What was it Giles said? Everyone's a 7 out of 10. Everyone scores himself a 7 out of 10.
Right, okay. So before we jump into the meat of the topic, before we go too much further, now we're going to go and have a look at what's been happening out there. And for that one, we are jumping into our segment, Dim's Golden Age. That sounds like this.
Step right up and take the stage. It's time
Our jingles are inherently
Dim's
long, by the
Golden
way.
Age. Ain't it great? Esports athletes share their flair. Dim's Golden Age beyond compare.
One day you're going to record that Giles style, full on with dancers.
Oh, yes! You're going to do it for Excel's 40th birthday.
Them just spread out on a piano.
Let's just say that Giles and I have rather different styles.
I hadn't noticed.
Yeah, people get us mixed up all the time. Such a similar approach.
It's that humble word.
So Golden Age update. I think Jeremy Jeremy said something in the WhatsApp group a few days ago, which I think kind of captured it nicely. Like not just this month, but like this whole year. The phrase was like that we're approaching escape velocity, the point where you literally couldn't keep up with all the free cases coming out if you tried. And my response to that was, I think we've passed it. Like, you know, 3 months ago, it was hard to keep up with. And then, Team Madagascar dropped like 30 cases in a month. And then Harry brought out his RPG that has like 100 challenges in it. I don't think there is a single person who has done all the free cases that have come out so far this year. And I say that as the person who, let's be honest, might have been the most likely to do it. Because I do play a lot of games in Excel. But anyway, that's the general vibe. But a few specific updates. I couldn't remember exactly what I had already covered in the last one, but we've definitely had a couple more regional competitions. So we had a Brazil round. We actually had 2 Brazil rounds, but I'll talk about the AI stuff separately. So we had an FMWC Brazil round, or I think they're now MEWC Brazil. And that was the last of their kind of regular season rounds, and then they're into like qualifier and knockouts after this. We also had the first round of MEWC South Africa. This is Friday. Yes, that was yesterday. Very fun case. I think, in my mind, the star of the golden age this month is definitely Harry Gross, because I think maybe I'd mentioned the role-playing game last month, but like it has grown, it has expanded. Crazy new things have been added. I don't know how many of you have been playing it, but it is like off the charts what he has done with it at this point.
Yeah.
Like everything about it, from the design and the gameplay, the weird thing about restricting functions so that like it's never the same if you played through the game a couple of times, but also the challenges he has added as this sort of final boss battle are bonkers. I guess we can talk more about that when we talk algorithms later, because when you mentioned that people like to push the envelope, I feel like Harry does more to push the envelope than anybody, in terms of he writes a lot of cases and he still holds himself to the standard of, I'm not going to put something out unless it has something new, something that hasn't been done. It's so that, like I said, is kind of the highlight in my mind. But a few other things that I know definitely happened since we last spoke. One is Jean Volle, who has been like one of the top competitors all along, suddenly abruptly became a case author, like dropped his first case and then his second and third and fourth within like 3 days or something. I've only played a couple of them so far, but they've both been phenomenal. And let's say above average difficulty. And I've got a couple more still to go. And then Andrew Robinson had a new one, Scary Speedsters, which is again pretty like fun, approachable, but the difficulty by the time you get to the end definitely dials up to 11.
Yep.
And then I guess the other thing, golden age-ish, is some of the kind of AI-specific battles. So there was, like I said, kind of 2 Brazil rounds. There was one last week for the regular competition, but then they had a kind of AI-specific demo battle on Monday that I took part in with Lorenzo and Eric and Thomas. Which that one did not go so well for AI, although it was a crazy case. But on the other hand, AI.
What was the structure of that one?
So that was they smashed together Fractal and Islands with AI in the middle, so it was the Fractal Islands, and it was I think it was like based on Catan or similar board games, with like hexagonal tiles. So you had this like big map with various subzones that were kind of like the equivalent of islands or continents or something. Zones that were the equivalent of islands or continents, and then subzones within those that were like tiles of sort of kind of a cross shape that tiled together to fill the thing in, and you had to do all kinds of weird things about like navigating from one tile to its neighbors, so taking kind of irregular step sizes, a little bit like not in Kansas anymore with the hex grid, but even more weird. and keep tabs of all the different things within each tile you had visited, and all the different which tiles had which number of neighbors and all kinds. It was very, I would say, it was quite unlike anything that had come up before, and it was a very visual one to kind of wrap your head around. And most of us were giving our instructions to AI in some kind of flattened into text form, and so it really struggled. Like I basically gave up. The idea was we were all supposed to be using AI, or AI assisted, and I was using Gemini, and it, like, I gave it the whole case setup, and it got level 1 wrong, and then I have it set up with a debug kind of thing built into the formulas. So I said, okay, put it in debug mode, and that threw an error as well. And I was like, I got to get on with this, or else I'm going to lose. So I just plowed on. I did a few levels, tried again. It was like, okay, I'm on level 4. Let's get its answer to level 4. And it turned out it had hallucinated various named ranges, which I've never known it to do before, but it did. And so I tried filling those in. Still couldn't get it to work, and eventually just played on and solved by myself. And that turned out that was the winning strategy, because all the people who were more pure about sticking to an AI attempt ended up with scores in the 200-300s. But I think the people who have played around with AI a bit would all tell you that that's probably not representative of how it's performing generally. So the South Africa round yesterday was won by Thomas playing AI. The last Road to Las Vegas round was won by Eric playing AI. The last FMWC UK round was won by Eric playing AI. I think we're going to see plenty more AI winners. But anyway, so that was a sort of exhibition battle, and then there's another one kind of still in progress that Julian Piltel is organizing, where we've all just kind of recorded solves separately, and he's going to stitch them all into a sort of pseudo live stream. So that one's still probably a couple of weeks from coming out, but that's also in the works. So yeah, lots going on. Busy.
Yet another exciting month of chaos
Escape
in the
velocity.
Excel competitive world.
Escape velocity.
Yeah.
We're going to need the first 2 hours of each podcast just to say what's happened in the last month by the end of the year.
Yeah, if it keeps going that way, wait till September. I'm just going to say.
And not only do we have the volume of all those cases, but the length of some of these test cases are also
Oh my God.
increasing
Yeah.
dramatically.
Yeah, you've done JJ's latest, right?
I have. That took me a good 3 hours, and probably more. I'm probably underestimating.
I dread to think how long that will take me. I'm just. I did yesterday's case for the South Africa case, and I actually answered everything and didn't get the answers right, but I answered everything within time, and I looked at the clock and I was like, that's never happened before. Whereas something that's taking you guys 3 hours, I'm going to be there a day later, just still doing a 24-hour live stream of Jack getting closer and closer to the ground.
So I tried to record my solve of this case. Actually, I don't know. I'm not sure how much we're supposed to talk about it, because he's only released it to beta testers yet, and I'm not sure what the destination of it is. So I'll just say I started solving it, and then I was like, okay, hang on, I'm going to need a lambda to get any further in this. Then stopped and wrote that lambda for an hour, and then came back and started again. And even then, it took me the guts of 2 hours from then. So yeah, that's 3 hours seems very reasonable to me.
I had that same process. I know the exact level that you got stuck on and needed the lambda, so I did the same thing.
Yeah, I mean, I don't think you could plausibly get past, you could do that level without it, but the whole thing, that level becomes just a single step in every other piece, every other iteration. I don't know how you could do that case without making that a lambda. Yeah. Which also,
I'm looking forward to probably not trying that case because I'm not sure I have the time in hand for that.
So funnily enough, my wife and kids were out for the day yesterday. They went on a puffin tour. We're in Scotland, and I was like, okay, so I've got one of Jean's cases and one of JJ's cases and the South Africa thing, and then that'll be my morning, and I'll go do a bunch of other stuff. And then it turned out John's case took like an hour and a half, and JJ's case took 2 hours after I had spent an hour preparing for it. So it was like, all right, well, I guess my entire day is doing Excel in one run. So okay. There are worse ways to spend a free day in the summer.
There are. I mean, I think some people would argue no, but I think within our circles, we've got a lot of.
I don't think those people are listening to this podcast.
This is fair. I'm going to guess the majority of people listening to this podcast probably have all of our phone numbers. All right.
Now.
Thank you for the update, Tim. It's it looks like we're getting into meatier and meatier cases that are being passed around. Kind of like below the counter cases, so to speak, that we've been having throughout the year. I was thinking we should probably, I know you've got a spreadsheet or something like that summarizing it. Well, you've got the spreadsheet that summarizes the main cases. Do we have any summary of these? Because we've had a couple of questions in our comments about where are these cases, who released this case, and so on. Local chapter cases, you get by signing up for the local chapters. But a lot of the other cases are under the counter cases where the community is just writing them for one another.
Yes. I mean, I always, whenever someone shares a case like in the WhatsApp group, I always ask them, hey, are you okay with me adding it to, the tracker and putting a link in there so that everybody can access it? And people sometimes people say, no, I want to keep this one, just me and my 200 closest friends. But usually they say yes. So I think I would say 95% of the free cases, as well as like all the regional and everything else cases are in my tracker. Usually with a lag of a month or so.
When you say 95%, is that the 95% that have errors in?
The 95% that have no formulas, no functions. I'll tell you something.
We're being honest, a fair amount of those do in fact have errors.
This is why they're below the counter cases. It's just.
Let me tell you this: if you play Harry's games, I can't remember if I explained this last time, but like the thrust of it is that it's a sort of Pokemon style game where you walk around and meet people and battle them, but instead of leveling up your Pokemon, you get access to more functions, and instead of choosing Bulbasaur or Squirtle or Charmander at the start, you choose XLOOKUP or Index or VLOOKUP, and you have to solve your first case using only that one function. And then gradually, at first you get handed like totally random stuff, like, okay, here's the sign function, and here's imaginary tan or other like totally bonkers stuff. So like to get going, you kind of have to solve your first few cases with like basically no functions, just like plus and times and copying cells around the place. And it really fills you with an appreciation for how good functions are when you go without them for a while.
I've not given it a go yet, but I watched the start of your video, Dim, and watched you claim that you were choosing XLOOKUP. Only to get stuck with Index, and I was like, I'm not going to watch anymore. Spoilers.
Oh yeah, so you if you had watched like 30 seconds more, I actually somehow, I think there was maybe a little bit of a bug at that point, but I somehow ended up with XLOOKUP as well.
Yeah.
Yep. But my first test of that
so
game.
Many functions in one, so as I have proven before.
You have quite rigorously. But yeah, my first playthrough of that game, I was like showing it to my 9-year-old who like loves Pokemon, and he was like walking around toy. It was like, oh yeah, there's Jack and there's Elliot. But then he went up and talked to Andrew and got the index function before I could stop him. I was like, oh, okay, I guess that's my one function
I
now.
guess we're going
I don't
with
even get to have
index.
I just love that.
All right.
He put me in the gym. Like,
right. So I am going to, from that point, lead us back into the juice of the algorithm conversation. So to get us started,
this isn't unpivot. We get quickly to the main topic.
Yeah, we get straight to the point here. It's only been half an hour, and now we can start
No
talking about
45 minutes before we start talking about it. Only half an hour. Come on.
Oh, look at the time. I got a joke, guys.
So to introduce us to algorithms, I'm going to ask our inherent Dr. Sorry, I can't stop calling you that today just because it's the topic. So I'm going to ask them, what is an algorithm for those people that are just sitting here going, what are you on about? Because we've been talking about lambdas. That's maybe a bit more accessible these days to people because, especially the crowd that tends to watch this tends to be into competitive Excel. But getting into algorithms, can you explain what is an algorithm and why do I need them?
Sure. I think the easiest way to think of it is like an algorithm is just a way of describing a process, like a series of steps to go through. Mm-hmm. So like a simple way to think about it, let's say somebody handed you a deck of cards and they're all shuffled and you want to sort them so that it goes, ace to king in whatever, hearts, then diamonds, then spades, then clubs. So lots of different ways that you could go about doing that. But say, for example, one of them would be, okay, you take the first card, boom, that's whatever it is. Then you take the second card and you figure out, is that bigger or smaller than the first card? And you put it either in front or behind. And then you take, for every card after that, you draw another card, you compare it to the top card. If it's, bigger than that, you take that out of the way, compare it to the next one, and keep going until you've found the right place to put it. And you do that with every card until you've, put every card in the deck. And like that is the algorithm for what's called insertion sort. Or is that? That's not bubble. No, that's insertion sort. Anyway, doesn't matter. Or, alternatively, you could say, all right, I'm going to take this one card, I'm going to put it here, and then I'm going to go through every other card and I'm going to sort them into the pile of the ones that are bigger than that one and the ones that are smaller than that one. And then, you've got your kind of separate piles. And then you go to one of those piles, take the top card of that, and you sort the rest of it into bigger or smaller than the top card of that. And you keep doing that until you get down to single cards. And that is the quicksort algorithm. Or you can say, you kind of lay all the cards out and, you take a pair of them and you put the bigger one on top. And then you take another pair of them and you put the bigger one on top. And then you take two of those pairs and you take the bigger one, like whichever of the top cards is biggest, you take that, and then whichever of the top cards is biggest, you take that, and so on. And you keep doing that until you've merged all the piles into one big pile, and that's merge sort. And like as a human, you kind of probably do something that's a bit of a hybrid of all those things. Like you'd probably sort them into suits first and then shuffle them around and whatever. But if you want to make an algorithm sort something, then you have to kind of describe it in quite concrete terms. And that, did I say make an algorithm? If you want to make a computer sort cards or do whatever else, then you need to describe it in quite concrete terms. And the bit that gets interesting, which I think is a relatively new thing for kind of Excel and esports, is the angle of efficiency. So, for example, if you take that first way I described of sorting cards, where you insert each card into the deck by just comparing it to the top card and then the next card and then the next until you find two that it slips in between. If you do that for, if you have a computer do that for a deck with 1 billion cards, it will take forever. Whereas if you have a computer do the one that I just the quick sort, where you take a card and split everything into above or below that, and then zoom into that and split everything into above or below the first card, and so on. If you have a computer sort a 1 billion item list that way, it will be way faster. And there's a whole kind of science around quantifying that. But the kind of big thing to know is an efficient algorithm, as your problem gets large, will be vastly faster than an inefficient algorithm. And that's why I said it's a relatively new thing, or a relatively unusual thing in esports land, because we don't usually have problems with very big search spaces where if you try to search for the solution in an inefficient way, it's really going to cost you.
Yeah.
Whereas some of the recent stuff, like some of Harry's cases, some of Jean's cases that I was just looking at this week, where you've got like you're finding unusual kind of distances between points that are million units apart, as opposed to our usual, like a map might be 50 by 50, then it really matters if you have an efficient approach.
Yeah, and I think one place where you do see that historically with the Lambda stuff is fee stacks, like I once produced and other people have produced similarly, where you say, I want to stack this thing 10 times, so we're going to stack it once, so we're going to stack a second one, a third one, a fourth one, a fifth one, versus the bi-col approach, which you've definitely shared before, with the bi-col is in BI, the bisection col, where it just splits it in half each time and then doubles it until it's got the amount it needs. Because if you're doing that 100 times, the amount of steps you need goes from being 100 to being 10 steps, and you go from linear to root, I suppose.
So the interesting thing in that one is you're doing the same total number of stacks, but the average size of the arrays you're stacking is much smaller. So when you do like stack one and one together to make 2, and then 2 and 1 to make 3, and then 3 and 1 to make 4, and so like you'll make whatever, if you have 1,000 elements to stack together, then more than half of your stacks will have an array of size 500, and whatever way they wrote VStack, that is slower. Whereas if you do it, I'll put these pair together, and then these pair together, and these pair, and these pair, and these pair, until you have 500 pairs, and then put pairs of those together until you have 254s, and so on. Then you still have to do whatever 999 connections to go from 1,000 separate things to one, but the average size of them is much, much smaller. And that is very much the kind of thing that in analysis of algorithm land we think about, or we used to think about. I haven't been there for a while formally.
So Jeremy, on your you've brought algorithms as a topic in, so presumably you've started using these actively now in your training in cases. I'm not sure if you've actively used many algorithms directly in cases, or maybe you've had them pre-built into lambdas that you're allowing for. But what exactly? So we don't exactly have a ton of sorting cases. I know sorting's your standard kind of like algorithm that you look at for kind of efficiency. But what sort of algorithms do you find yourself using and learning and trying to get better at for esports purposes?
Yeah, I would definitely say learning more than using, at least within the confines of a 30-minute case. Typically speaking, you're not going to be writing a lot of algorithms. But it is useful in an after the case or before the case, if you're anticipatory, to think about how was there a better way to solve that. So jumping to specifics, if we tackle one of Jean's cases this week, it was about banks, and you're supposed to go to a variety of banks and try to get a certain target amount of currency with as few notes as possible. And you're only allowed to go to one bank to get one currency total. So it's an assignment problem in combinatorics. It's called the assignment problem, where you have to match this bank to this currency total, this bank to that currency total, 1-to-1 assignments. And I think the way that most of us initially intuited to solve it was brute force. Come up with every permutation of currency to bank combination you could come up with, calculate the totals, and pick the smallest one. Now, in that case, it was feasible to do it that way within Excel, because I think it was a 6 by 10 grid, and there ended up being like 700,000 possible permutations. And in Excel, we can do up to 1 million rows, so that was doable. but it got me thinking, A, is there a faster way to do this? I don't use percom. I have it on my to-do list to create some sort of permutations handling lambda, but it's not there yet. So I didn't have that immediately accessible. And I was wondering, is there a more elegant solution to this approach? It seems like, okay, probably a problem that someone's tackled before. Sure enough, I look into it, and there absolutely has been. In fact, it's been a vast amount of research on this. And a guy named Mr. Kuhn from, I think he was born in Santa Monica, where I live. He invented this algorithm in the 1950s. And I thought that was really interesting. I started learning the backstory, kind of went down a rabbit hole. This guy went to Princeton. He was there with John Nash. You know, if you've watched the A Beautiful Mind movie, he would have been one of the guys, you know, hobnobbing with John there. And I learned about the algorithm. I spent hours just kind of like figuring out what all this stuff means, because honestly, it's technical. It's over my head. But the beautiful thing about an algorithm is it ends up just being steps. Even if you don't learn all the, you know, notation behind everything, if you can follow instructions, you can do it. So I spent probably a good part of a day figuring that out and going step by step and building it in Excel. And it got me thinking more about algorithms in general. Hey, what else is there out there? I've definitely been I've definitely been adjacent to the Dijkstra algorithm with the map finding or path finding and things like that. It's been made aware to me that there are algorithms to solve that one case that Harry did. I think it was level 7 for we're not in Kansas anymore with the water flows cascading down through the pipes. So it seems to me like this is the frontier, and I'm the tinkerer right now. I definitely don't know a whole bunch of different algorithms, but I'm learning how to maybe design a system of thought around it and how to start implementing them in Excel, which wasn't always easy to do, like probably impossible. Maybe you could do it in VBA, but until dynamic arrays, lambda, let, probably a lot of this would not really be feasible. But now it is, and if we're talking about pushing the envelope, this feels like something I can do.
Yeah, for sure.
Did I talk too long?
Oh,
Absolutely not.
At least not for me. I thought it was all interesting. I was going to say, I feel like kind of maze navigation is the sort of the algorithm that the most like esporters will have given consideration to at one time or another.
Yeah.
And like it's a good in my mind it's a good example because it is just a kind of case of you do exactly what you might think you do, which is to say, okay, well, you have to start from here. So where are all the places you can get to in one step from here? You know, let's not talk about variable cost for now, but that's a whole other thing. But, you know, if it's just, you know, what is the minimum number of steps to get to an exit or a gold chest or whatever, then it's just, okay, well, I can go up, down, left, or right in one step. And so now I've got 4 locations that I can be at. Well, from each one of those, I can go up, down, left, or right. And that gives me some set of locations, but then some number of those are going back to where I started. So I don't want that because that's never going to be the best path. And some number of those combine. So like, you know, going left and then up and going up and then left get you to the same place. And so, you know, if you think about it in terms of, okay, rather than saying I have 4 steps and then, you know, 4 squared and then 4 cubed, and then that's going to blow up way too quickly. But if you think of it as, well, I'm going to cut off the places that I've already been to before, because going back where I've been before is never the most efficient. And I'm only going to consider the unique locations because, you know, from here to here, if you can get there with, you know, any combination of 10 ups and 10 rights, that will be like 20 choose 10, a squigillion different paths, but it doesn't matter because it's all 20 steps to get from here to there. And like that already is, like a little bit of like dynamic programming, kind of keeping tabs on what's the most efficient way that you can get to here. And again, it's a little more simple in the case of just how many steps does it take, because then once you've reached a place, you know, there's never going to be a faster way because you're only thinking about, okay, now I've done n steps, let's do n plus 1, let's do n plus 2. If you have variable distances, then it might be, you know, I've got to a place in 3 steps, but they're very slow. But actually there's this, you know, super highway that goes around and it's much longer, but it'll get you there in no time. That makes it a little more complicated. But the sort of basic idea of, let's only keep track of unique locations and let's not go back to places we've been before. That's already, that is your standard breadth first search algorithm, and
Yeah.
that's like implementing it, especially implementing it as like a single cell anything, is quite hard. But actually understanding the idea of the algorithm is not that hard. It's just like, okay, well, these are the places I can get to in one step. So where can I get to in 2 steps? I'm adding in these places. Okay, so now where am I adding on the 3rd step, and so on. The idea, the principle is quite simple.
This might, I mean, it was talking about those examples you gave and maps in particular. It really kind of feels like the first time that this type of thinking was introduced. So if you look back at like Bear Island or Land of Banana, where you have to think that logically through. Maybe you've never been trained on the algorithm, but you think about how could I do this? Well, you may need to know that circular logic is a thing and whatnot to turn that on. You learn that after your first video. So after going back to the lab, now you start plugging away at that logic. You're doing your own algorithm. It may not be the most efficient algorithm. It may not be the best way to do it, but that is an algorithm. That's the essence of it. If you've got steps that you can logically think to break down a big problem into smaller problems and finally get to the solution, that's algorithmic thinking.
So a lot of MEWC people think of Bear Island as like the OG maze, the OG map. But for me, the OG was my first model of finals back in 2013. There was like, some huge crazy project finance modeling thing for 2 hours, and then there was a 20-minute problem solving case, which was navigating a maze and figuring out the minimum number of steps to get from the start to the end. And I had never heard of circular references as a way to do this, so I literally had one sheet with the entire maze and just a 0 in the starting position, and then 60 more sheets, each one referring back to the sheet before, with one more step, one more step, one more step, one more step, one more step. And by the way, like, I ran away with that challenge. Like, I was the only person to get it done in 20 minutes. Like, coming up with that was already, like, at that time, that was cutting edge. But yeah,
I mean, I'm guessing now with
the
the advent of lambdas, with us being able to use array formula with Python in Excel, which I've actually seen drop off the radar a little bit, we've got a lot more opportunity to have algorithms effectively be written in single cell formulas and single cell solutions.
Yes, 100%. I mean, I feel like, Jeremy described himself as a dabbler. I would describe myself as more serious than a dabbler, but I don't think there's any question that, like, Bo is 10 steps out further on the frontier than any of the rest of us. Like, so you mentioned the, Harry's Kansas case that has this like network flow graph. Bo did a whole, like, hour and a half plus live stream developing the Ford Fulkerson algorithm for finding maximum network path flow in a single cell formula. He's got a Hungarian algorithm, the assignment thing that Jeremy described, as a single thing. He's got a bunch of different like breadth first search maze solvers and Dijkstra, and he's like, if you want to kind of witness the cutting edge, that is where you need to look.
Keeping it, I'm not sure I can keep up with the number of Bo videos though, because especially with the advent of the Harry Gross game and some of the longer cases that are happening now, you do end up it's just these really long Bo videos that have become kind of like something that goes on in the background in the evening while I'm working on something.
I mean, it's a fair point. There's a gap in the market for a sort of curated Bo feed, because he does have like, he has. I remember he did a video recently after one of the MEWC Brazil rounds that involved permutations and combinations, and he's done it a few times with the maze thing. But like, he has all these lambdas, he has all this kind of pre-built stuff. He seems to just prefer to build from scratch most of the time when he's solving. And so he does, like
Yeah.
what I was describing of, okay, so these are the places I can get to in one step, in two steps, but now you can see I'm going back, so I have to, get rid of places I've been before. Now you can see there are duplicates, so I have to get rid of that. Now you can see there's this, now you can see there's that. Like that development process, especially for the maze one, he's done that kind of from scratch a bunch of times. He's done percom from scratch a couple of times on his videos. Like he has lots of others that are not, developing algorithms that you'll use on 50 other cases, but ones the ones where he does, like he's actually very, very thoughtful about kind of going into the full detail of it. So yeah, maybe there needs to be like a playlist of, Bo's algorithmic greatest hits or something. Yeah.
I'd want that.
And those are just the macro tips. I find I learned so much from Bo just at a minuscule, like minor detail point of formulas that I've never considered or understood very well before. He's got implicit intersection tips. He's got I'm running into a lot of problems about one arrays of one value and things like that. And every time I see Bo post, I make sure you gotta stop, slow down, and spend 10 minutes digesting that.
Yeah.
Yeah. I mean, he is a master of his craft.
Yeah, no, absolutely. He's joined a couple of the full stack sessions that I've done and just posted solutions that boggle your mind as to how simple it is once he explains it. But you're like, there's a level of understanding of what goes on under the hood that my brain is never going to reach. See through the matrix almost. But when you were saying about like a Bo best of Bo, my mind immediately went to, I don't know if any of you follow any of the coffee YouTube scene. Probably two. This is why I don't have enough time for the Excel YouTube scene at the minute. Too busy watching the coffee scene. There's a UK coffee guy called James Hoffman, makes great videos, but there's somebody that has a mock account called Hames Joffman, where they take clips of things that he's said and like cut them together. So it'll be a 20-minute video of him talking about something, and they'll cut it down to it'll be how to make the best coffee-based recipe, and they'll cut it down to him talking about how much he hates people who come into his coffee shop or something like that, just by splicing it. And I think we need, maybe not the Excel is Exard, but maybe Ian Durley coming in. Someone making those videos of taking clips of you reacting to trying to goad me into look at it. I'm using XLOOKUP type comments into some sort of.
Look, Elliot, I'm using VLOOKUP. Usually what I say.
For that.
I'm just gonna throw it out there. What about ear dimly? I feel like that would roll a bit better off the time.
There we go. There's your challenge. If you're watching this, by the next time we record, we want to have an ear dimly.
An ear dimly channel just kicking off.
Harry was joking about making a supercut because I spent basically recorded a video pretty much every day for a week of playing his case. I think I had 7 or 8 hours of videos in the end. But he had this idea of making some kind of supercut of maybe every time I said, wait, do I have if? Wait, do I have some? Wait, do I have? It's always the same bit of the screen that I would stop and glance over to. Wait, do I have? Oh no, I don't have that. Oh yeah, I have that. There's all kinds of things that could be done here.
Do you guys think there's any benefit for? I mean, obviously we're learning by watching Bo in most cases, and then the rest of us are learning by watching Dim, and then we're learning by watching everyone else's videos as notions trickle down. Is there any benefit to really going deep and learning some kind of pre-existing algorithms, the named algorithms out there? Because obviously we've touched on a few of those throughout this evening, and then thinking how those might be applied, and building up from there.
My answer to that would be benefit of named algorithms very low. Because basically, if an algorithm is specific enough for one person to get their name on it, it's going to be used for either 0 or 1 cases ever. So I had a moment of great joy when, like, one of Harry's questions was like, here's a list of 10 universities and a list of 10 candidates applying to universities, and each university has an order of preference over the 10 candidates, and each candidate has an order of preference over the 10 universities, and you had to come up with an assignment of candidates to universities so that there was no candidate and university that could both be happier by breaking the arrangement they had and connecting together instead. And it happened that, like, 10 years ago, I had basically this same problem with, like, the summer interns at Deutsche Bank. My boss came to me and was like, hey, HR are, like, turning this 11-dimensional Rubik's Cube for a week to figure out the best way to assign people to groups, because groups have an order of preference on people and people have an order of preference on groups. And it's so much work because, there were like 100 and whatever, lots of people. And so I did some Googling and found out that, this was basically a solved problem in economics. And there's this algorithm called Gale-Shapley that is used, for example, for, like, matching doctors to, graduate medical schools, and for various other things. And so I, like, built an implementation of that algorithm, and we used it to assign our summer interns. So then I saw this and I was like, oh, Gale-Shapley. Not to be clear, Gale-Shapley as in I can immediately code this, but Gale-Shapley as in I can go to Google and look at the Wikipedia page.
I can go to Google and remind myself what I did before. Yeah.
And then I can implement that quickly, a lot more quickly now with dynamic arrays than I could in whatever 2017 or so, the first time I did it. But that is literally, in the 10 years since I did it, that is the only time I've used it. And I don't expect to use it again in competition. And I would say the same is true if you do the, like, network flow, like Ford Fulkerson. I think if you want to learn things that will help you over and over again, I would say number one would be, like, the basics of breadth first search. So breadth first search basically being like you're navigating a network from a starting node, and each node, can lead off to some further sub branches. And you're basically kind of searching one layer of that tree at a time. To say how many steps will it take you to get out of the maze or something like that. Like each location is a node, and each node is connected to the different places you can get to from there. Like that style of approach will come up over and over again, or like to a lesser extent, but the dynamic programming, the thing that came up with the original Lana Banana, where actually, when we're talking about algorithms, I think you couldn't talk about algorithms in esports without kind of mentioning Lana Banana as a sort of turning point moment.
I don't have any Lana Banana shirts nearby.
We know you have it though. We know you have it. Because it, like I said, typically esports cases are not written in such a way that, there it is, Lana, are not written in such a way that there's a big emphasis on efficiency. Like if you can do it at all, and maybe it'll take you 5 seconds to calculate instead of a quarter of a second or whatever, but it'll get done. And Lana Banana was probably the first thing where if you tried to brute force it, it was literally impossible. So the idea with Lana Banana was, you were kind of going down a hill, and at each step you could either just go down, or you could go down into the left or down into the right. And I'm probably mirrored and doing that wrong, but never mind, you get the idea. And so, and you had to figure out the most number of bananas you could pick up along your path. And so if you tried to do that from the start to the end, then it literally is like, well, there are 3 places you could be on the next step, and 9, not 9 places you could be, there's only 5 places you could be, but there's 9 paths you could take, and it does matter the path. So it's it's not like the maze where you can say, well, any path that ends at this point and takes the same number of steps is the same. It wasn't. And so if you had to go 30 steps down, brute force.
I remember the moment of realization after the fact when. Was it your solve, or was it someone just mentioning in the chat or something like that? because I feel like this was in the early days before we had the full-on WhatsApp groups going on.
Yeah.
And seeing that sort of that moment and going, oh my God, that is so simple. The approach is bottom up, not top down. And
Yep.
that sort of made such a huge difference. And like, as you say, that was a key point in time.
But like that, exactly what you just said of like, oh my God, bottom up instead of top down. Like, not to say that there's not any more to dynamic programming than that, but like that is the gist of dynamic programming. That's like the nice thing about that case is it basically teaches you dynamic, like either because you see it or because you battle it hopelessly and then you find out later. But you know, that's also a great way to learn things in a way that they'll stick. Yeah, it's like I think of that as one of the first where it really was like it wasn't kind of you'll do it slow and it'll take 30 seconds to calculate, or you'll do it fast and you'll be quick. It was you'll do it fast or you will not get it done. Not even close to being close.
Right. Okay,
Adding on to
that
Dim's answer.
topic. Yeah, sorry. Going ahead. I'm trying to cut you guys off so we don't go on too long, but let's close this one out.
Yeah, I was going to add on to Dim's answer. I agree that there's not much sense in learning specific like named algorithms. It's not going to help you in very many cases. But I do find that, at least in my initial journey through this process, is that it's helping me with the Excel implementation side of things. Right. So if you think about recursion, a common thing that you'll use in algorithm, recursion is tricky if you're not born with a computer science gene, right? So and doing it in Excel in particular is even trickier because of the way that you can't self-reference variables like within a let, for example. So you have to learn workarounds in order to do it, and the more that you kind of drill those with a few different types of examples, there is some sort of generic like skills that you build up over time in doing a variety of different algorithms. So I mean, like I said, I've only probably done 3 or 4 named ones this year, but that process of going through step by step methodically learning how to do it has made a general like building block of knowledge, of understanding of how like flow control can work in Excel when normally you would have to do like VBA traditionally. Now I can do a little bit more in the cells, and so I think that's been helping.
Yeah, I totally agree with that. And like I think the more that you get a sense of patterns that keep like the pattern of writing a recursive function, like that takes quite a while to wrap your head fully around. But once you get the hang of it, that is something you'll use again and again.
Okay, so some great lessons learned and things to look into there. I really love your point about flow control on that one, Jeremy, because I honestly just think of it in terms of VBA, and I can manage the control of flow of data through that, but the control of flow within formulae is getting more and more complex. So that is a great thing to actively be learning. So I'm going to take us into our final segment of the podcast. Now, what I haven't told the guys today is I've decided to kill VLooky and XLooky.
Oh no!
I'm ready for that.
VLooky and XLooky are dead. It worked the first time. We were pushing it the second time. So what I've done is I've kind of gone blatantly against what Dim said in the first episode, and I've created a new segment, and this one is actually called Excel Hot Takes. So here is our jingle.
Excel Hot Take. What will they say? Is this array in disarray? Excel Hot Takes.
And we are on to Excel Hot Takes. And in this new segment, just to close us out with a bit of fun, I've put in a few random Excel hot takes that I've gleaned from the internet or from my own brain, and I've dumped them into a OneNote document for our producer, Johnny. I have no idea what we're going to be discussing because he is going to randomly select a topic for us to have a hot take about, and he's going to tell us that now on the stream. Oh, I love it. Okay, so for those of you that can't hear this, he has rolled a 1d8 to decide our topic.
This is as
And
good
it is?
as Harry Ross's live topic generation on his live streams.
Yeah.
The hot take for this week
So-
is
so-
Google Sheets aren't that bad. I will stand by Google Sheets are not that bad.
I think I'm actually in there too. Like, I can't use Google Sheets to solve an Excel competition case, but it has a place and a time, I think.
Totally. I mean, honestly, some of the stuff that I got into Google Sheets for, maybe if I was doing it today, I wouldn't need to because of Office scripts and stuff. But like, the big example for me is we've had like a nanny since my wife went back to work after first maternity leave. And there's a whole bunch of stuff to keep track of, and like on the payslip of like hours and overtime and Social Security and Medicare and blah 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 blah. And so we need to kind of send her a payslip every week. And so I've done that in Google Sheets right from the start, because you could do something kind of VBA-ish, except it runs in the cloud. And so, every Friday morning at, between 7:40 and 7:45 a.m., I get an email with, hey, here's this week's payslip, that I can then, forward on and also take as a reminder to transfer money and whatever. And even now, I think it's doable, but it would be hard work to do it with pure Excel Online and Office scripts. And I'd set that up 9 years ago in Google Sheets.
Is that not a feature that is coming out soon, that you will be able to kind of run kind of
9 years
stuff?
later. I did not have the option to wait. Google Sheets was there for me, man.
It's like for 9 years. I mean, my personal experience with Google Sheets is I don't use it a lot. I've never really needed to, because I'm using Excel in work environments or jumping into competition. But I've developed a slight obsession with pretty spreadsheets lately. And Google Sheets has an amazing ability to create these beautiful looking spreadsheets that, just look really pretty. Visually, you can create something that you can't always create in Excel.
Really?
So that's my point for that. Yeah. There's one TikTok account that I follow, and she just creates these amazing. She's got finance dashboards and stuff like that. But there's one where it's kind of like just a library, and because it's layering images inside the Google Sheets over the coloring that's kind of applied in there, and then they're doing individual things to track like books. So she clicks on books that she's read and stuff like that. So yeah, it looks pretty good, and creates a virtual library in front of you that you just click on a book.
I think if we're going based on prettiness, I think technically numbers. Is it called Numbers? The Mac spreadsheet one.
Oh, he went there.
I've legitimately never used that one.
Apparently, it's very. I've never used it either because I'm not rich enough. But apparently, it is pretty.
Okay, Jeremy, do you have a preference for non-Excel spreadsheets? And we're not going as far back as Lotus right now, so.
I don't know any non-Excel spreadsheets. To be honest, my impression is that without Google Sheets, that perhaps we wouldn't have had as much investment in Excel from Microsoft, and for that reason, I'm very thankful about it. But I never use it myself.
Okay, that's actually a really good point.
Yeah, I think that's a great thing. Your favorite coffee shop isn't your favorite coffee shop because it's the only coffee shop. Unless you live where I live.
So what you're saying is Google Sheets is the other coffee shop.
Yeah.
Yeah, but sometimes I'm on the other side of town and I go to the other coffee shop.
Yeah, because it has functions that.
I would not do a Road to Las Vegas battle in Google Sheets unless it was kind of on a dare, which I have not ruled out doing at some point in the future. But I wouldn't if I wanted to get my best result. But there's lots of stuff that I am a relatively heavy Sheets user, and it's a totally different part of my brain and part of my life than either competitive Excel or most of my client. Where I have actually built financial models for one client in
In
Sheets,
Google Sheets.
and then had to export it to Excel to give it to their investors, because of course their investors aren't using Sheets. But
Brilliant. Right, so that is the end of our new segment. Because I love the jingle that much, I'm going to play it again for you guys.
Excel hot take. What will they say? Is this array in disarray? Excel hot takes.
That's also one of my shorter jingles, you'll be pleased to know. I decided not to make it as long as the XLooky versus VLooky drama startup. So.
it's very I like is this array and disarray. That's catchy.
Thank you. No, I did that one myself. I actually took what AI gave me and said that doesn't work and completely reworked it into actual lyrics that work. At some point, we're going to be debating whether an array is in disarray during Excel hot takes, and it will rarely come into play then. Right. Well, thank you, Jeremy, for joining us today. I'm actually going to close this out at this point because otherwise everyone's going to have to watch a 2-hour podcast. So I don't think there's going to be too much clipped from this one. We should be kind of looking at just over an hour for this one, and it should be out soon. Thank you very much for joining us. Next time, we will be having the Excel man, JJ, joining us from Chile. And yeah, we'll see you then. So from Jack, I'm going to say goodbye.
Goodbye from me.
Bye from me.
Bye, guys. That was a blast. Thanks.
Great. Thank you. Today's episode was brought to you by Elliot's favorite coffee shop. Please subscribe to stay up to date and comment with your own Excel hot takes.